bullets fired through rifled firearms receive both the class as well as accidental characteristics of the barrel from which they are fired. The bullet will show not only the primary markings left by the lands and grooves of the gun barrel, but will also reveal fine striations in all the marks. These are nothing but the imprint of the small irregularities in the barrel and are never duplicated by different weapons. To determine whether or not a particular firearm has fired the questioned bullet, a detailed comparison is made of the markings on the questioned bullet with the corresponding markings on the test bullet fired from the suspected firearm. A bullet comparison microscope is used for this determination. The suspect bullet and the test fired bullet are both illuminated obliquely in order to create shadows that reveal the ridges and furrows engraved by the firearm. Comparison microscope, and how is it useful in identification? Let's see that. Comparison microscope is probably the most important and the most widely used scientific instrument in a modern crime laboratory. The first comparison microscope to be used in the field of criminology was a very crude instrument compared to the nowadays highly developed instruments available. It was designed by Albert S. Osborne for the application in the field of document examination. A comparison microscope consists mainly of two compound microscopes having identical optical systems so that they give the same magnification connected by an optical bridge containing a combination of prisms such that by viewing two separate objects, one under each microscope, through a single eyepiece, the two objects may be compared by bringing the images of the parts of each into juxtaposition. The optical field seen through the single eyepiece is a circular area which is divided into two parts by a thin dark line. The object under the left hand microscope, say the evidence bullet, is seen in the left half of this optical field, and the object under the right hand microscope, say a test bullet, is seen only in the right half of the field. Let us come to the examination of bullets. A bullet is a projectile which is fired from a rifle weapon and is a part of rifle cartridge. The bullet, while passing through the barrel, gets the following characteristic of the barrel: class characteristic marks of the barrel, accidental characteristic marks or individual characteristic marks. Now, class characteristics consist of number, width, depth, direction, angle and pitch of lands and grooves on a fire bullets, and would be common on bullets fired from firearms of the same make and model, but would be different in respect of different makes and models. Class characteristics are thus useful only to the extent of quick eliminations. Coming to the individual characteristics, finer details in the lands and grooves are the individual characteristics of the firearm. Individual features are helpful as they are always different and no two firearms have the same characteristics. These characteristics are really useful in comparison of bullets. Individual characteristics are the imprint of the small irregularities in the barrel and are never duplicated by different weapons. A comparison of the question bullet and sample bullet. Let us consider that. Now, while question bullet may be found at the scene of crime or removed by doctor from the dead body of the victim, the sample bullet or a standard bullet needs to be obtained from the recovered weapon. There are various methods for recovery of fired bullets, and one of them is firing the bullet in a water tank and its recovery from the tank. In India, most of the forensic organizations use bullet recovery box for recovering the fired bullet, that is the standard bullet. In shotgun ammunition, there are a number of wads and comprises of over powder wad, air cushion wad, undershot wad and overshot wad. They keep the powder charge in the cartridge in their proper place. In addition, the cushion wads seal the barrel on firing and thus prevent escape of gases and consequent loss of velocity. They also clean and lubricate the barrels. Over powder, undershot and overshot wads are made of special quality cardboard varying in thickness from about 2 to 3.5 millimeter. They are indeed waterproof. They are certainly larger than the bore of the firearm for which they are intended. Let us discuss the wad diameters of various shotgun ammunition. Coming to the size of bore 10, then the bore diameter in inches is 0.775 while in millimeters it is 19.7, and wad diameter in inches is 0.784 and 19.9 in millimeters. For bore 12, the bore diameter in inches is 0.729 while in millimeters it is 18.5. And wad diameter is 0.738 in inches and 18.7 in millimeters. For bore 16, the bore diameter is 0.662 in inches while 16.8 in millimeters, and wad diameter is 0.671 inches while 17 millimeters. For bore 20, the bore diameter is 0.615 in inches and 15.6 in millimeters, while the wad diameter is 0.623 in inches and 15.8 in millimeters. For bore 24, the bore diameter is 0.550 in inches and 14.0 in millimeters, while the wad diameter is 0.557 in inches and 14.1 in millimeters. The modern shotgun wadding has undergone several changes in the last few decades. The following changes have been made. The base wad is plastic mold and fixed in the base of the brass head under pressure. The over powder wad has changed to an inverted cup wad open side towards and over the powder, so that when the gases are formed, the lip, that is the open round edge of the cup, is pressed with pressure against the barrel and thus it seals the bore. It thus prevents the escape of gases from the sides. The cushion wad's function is carried out by the cup wad and piston, which is attached to the rectangular projectile sleeve containing and protecting the projectiles from coming in contact with the barrel and consequent damage. The sleeve has cuts along the edges in its frontal part. The four sides of the sleeve open up and fan out along the cuts when the sleeve comes out of the muzzle. The sleeve gets separated from the projectile charge. The sleeve being lighter falls down. It does not interfere with the shots in their flights. The buckshot in a cartridge has spaces which are filled with granular plastic material to cushion them. The plastic granular material prevents damage and provides uniform push to the projectiles. They ensure proper push to the projectiles, give a better spread and uniform velocities to the buckshots. The above innovations have improved the aim, range and ballistics of the shotgun cartridge considerably. Coming to the Wad distribution, wads are found in shotgun ammunitions. They are projected along with powder charge. They enter the target of up to a range of about 3 meters. If they are not obstructed, they scatter from 5 meters to even about 10 meters or more. If the distance between the victim and the wads is known, the range of the firearm can then be determined. A more accurate estimation of range can be made by test firing with the suspected firearm and similar ammunition. The weather conditions will also have an important effect upon the scattering of wads. They may not be blown far away or retained near depending upon the direction and velocity of the wind at or immediately after the time of firing. The weather should therefore be taken into account for the determination of the range of fire from Wad distribution. The cushioned wad, being heavier, goes to a much longer range. Formerly, the identification of buckshots and pellets fired through a smooth bore firearm was considered impossible. It appears that buckshots packed between the wads in a cartridge are pushed through the barrel without any appreciable sideways or turning motion. The buckshot and pellets on the periphery scratch against a segment of the inner surface of the barrel. They take up the marks from these segments corresponding to a land in the rifle barrel like bullet. The marks have been found consistent to a given segment of a barrel. Test marks are obtained on a specially prepared slug which fits in tightly in the barrel. When it is pushed through the barrel without turning motion or fired, it takes up marks from the whole internal surface of the barrel. The comparison of the marks on buckshot or pellets with the marks on the slug is carried out with a comparison microscope like a bullet. Buckshot and pellets are sometimes housed in a sleeve placed in a cartridge. The sleeve protects the pellets or buckshots against the scarping in the pellets. Such buckshot or pellets will not take up the barrel marks. Coming to the pellet patterns now. The area covered by pellets fired from a shotgun is proportional to the distance between the muzzle of the firearm and the target. Greater the range, greater is the area covered. The spread is affected by the length of the barrel of the firearm, the muzzle of the firearm, that is whether it is choked or not, and the condition of the ammunition. If test experiments are performed with the suspected firearm and if the ammunition of the same make and batch is used, the pellet patterns provide fair estimate of the range. Generally, in a standard shotgun, the whole charge enters the body and masks up to a range of about 2 meters, forming a rat hole varying in diameter from about 2 centimeters to about 6 centimeters, depending mainly upon the distance between the muzzle and the target, the construction, that is a choke of the muzzle, and the size of the pellet charge. There is a rat hole surrounded by individual holes from about 2 meters to 7 meters. In buckshot charge, the individual shot may form its separate hole from a range of 3 to 4 meters. The separation of the holes is usually complete from about 10 meters onwards, especially in buckshot charge. The spread of pellets at various ranges with different degrees of chokes is given below for a rough estimation. Now, the first column is going to be the range in meters and then the spread circle diameter in centimeters. Now, if the range is 10 meters, then the spread circle diameter for a true cylinder will be 54 centimeters, for improved cylinder 38 centimeters, for half choke 31 centimeters, for full choke 23 centimeters. For 15 meters range, the spread circle diameter for a true cylinder will be 71 centimeters, for improved 55 centimeters, for half choke 44 centimeters and for a full choke 66 centimeters. For a range of 20 meters, the spread circle diameter would be for a true cylinder 88 centimeter, for improved cylinder 89 centimeter, for half choke 58 centimeters and for full choke 45 centimeters. For range 25 meters, the spread circle diameter for a true cylinder would be 105 centimeters, for improved cylinder it will be 89 centimeters, for half choke 73 centimeters and for full choke 59 centimeters. For 30 meters of range, the spread circle diameter would be 122 centimeters for a true cylinder, 106 centimeters for improved cylinder, 90 centimeters for half choke, while 75 centimeters for full choke. For 35 meters of range, the spread circle diameter would be 140 centimeters for a true cylinder, 124 centimeters for improved cylinder, 108 centimeters for half choke, while 94 centimeters for full choke. This table is not, however, applicable to improvised pistols and guns made illegally by local blacksmiths which do not conform to specifications. The barrels are either too loose or too tight. The length of barrel is often short. The inner surface is often rough. Consequently, the spread of pellet is not only different from standard firearm, but it varies in the same firearm from one shot to another. These firearms do not lend themselves to reliable range determinations. For standard firearm with half choke, a rough idea of the range is obtained from the fact that every meter of distance is equal to 3 centimeters of dispersion. Mathematically, D is 3R, where R is the range in meters, while D is the diameter of dispersion in centimeters. The country-made firearms are improvised by the culprits from readily available materials, either personally or with the help of a local blacksmith. As the legal possession and legal trace is highly restricted, the needy clientele has to go in for the country-made firearm in a big way. So much so that in India, a fairly large percentage of firearms used in crimes is of the improvised variety. In addition to it, comparison of bullet and cartridge cases is carried out with the help of comparison microscope. In case of shotguns, pellets are identified with the help of scratch markings, if at all any is present.